and welcome to today's lesson. We are going to look at water on Earth. First, it is important to note that the largest part of the Earth's surface is majorly covered by water. About 70% of the Earth's surface is covered by water. That is the waters in the oceans, sea, lakes, rivers, and so on. So the largest percentage of the Earth's surface is covered by water. Then almost 97.5% of this water on the Earth's surface. We are talking about 70% of the Earth's surface is covered by water. But this water on the Earth's surface, the water that is available on the Earth's surface, 97.5% of the water on the Earth's surface is salty. So what are we left with? We are left with 2.5% that we are talking of the fresh water. So 97.5% is salty, 2.5 is fresh. So we are having the fresh water that is available for use, for consumption by human beings, plants, and animals. The one that is available is only 2.5% of the 70% water that is covering the Earth's surface. So this 2.5% of the water that is fresh, not all of it is on the surface of the water. We are having about 0.01% is the only water that is available for renewing and use. The rest of the 2.5% of the water that is available is found underground. So the water that is available for use is 0.01%. So what are we saying? That there is very little water that is available for use on the Earth's surface. This 0.01% of water is the one that is available for use, and as it is being available for use, it is undergoing a cycle so that it is continually going to be supplied on the Earth's surface. So we are going to look at the water cycle, the 0.01% of the water that is undergoing the water cycle. We are going to look at the process or the states in which this water is changing in order to be available for use for various activities on the Earth's surface. So we look at the water cycle. We start by asking ourselves, what is this water cycle? Water cycle is simply the natural process of recycling water. The natural process through which water is going to change its states from liquid, solid, gaseous, and back into a liquid state is whatever we are referring to as the water cycle. So as the water is undergoing this natural process so that it is recycling itself in the process, we are having it changing its states. So it changes the states from water in a liquid form in maybe water bodies, that is oceans, seas, lakes, and so on. So this water in a liquid state changes into water vapor. The water vapor through condensation process and so on will also change into clouds. So the clouds that are formed when the condensation process go beyond, we find that the clouds will now fall down as precipitation. So we find that water has changed its state from liquid form into gaseous form, into a solid form, and finally back into a liquid state. So this is what we are referring to as a water cycle. So we want to look at the process of the water cycle in detail and find out how are these states of the water changing from one form into another. So So what happens is this: when energy from the sun hits the water bodies, so we are having this energy from the sun heating up the water bodies. When the water in the water bodies is heated up, what simply happens is the water evaporates. So the first thing, we are having the sun providing us with the energy so that this energy heats up the waters in the water body. Then evaporation process takes place. So the water bodies, we are having things like ocean, we have seas, we have lakes, rivers, and so on. So we are having water in this water body being heated up by the energy from the sun. Then it evaporates into the atmosphere. As it evaporates, as it rises up into the atmosphere, the water, in this case, water was in a liquid state. As it evaporates, it changes its state from the liquid state into the water vapor. So this water vapor, as it rises up in the atmosphere, you discover that we expect in the troposphere layer of the atmosphere, as you move higher into the atmosphere, the temperatures lowers. So since the temperatures is lower in the higher levels of the troposphere, then as this water vapor is rising, it ends up cooling at a certain point in the atmosphere. So we find that the water vapor cools, so that as it cools, there is a certain height where the water vapor the air cannot hold the water vapor anymore. So since the air cannot hold the water vapor anymore, we say that this air has reached a point that is known as the saturation point. So the point at which the air cannot hold the water vapor anymore, we refer to it as the saturation point. So at that point, any more water vapor that will be added into the atmosphere will simply condense. So as it condenses and forms the clouds. So we are having formation of clouds that will occur as the process of condensation takes place. So clouds have been formed at that point, but there is still water that is evaporating. So what do? if continuous evaporation takes place and the air has reached its saturation point and there is still more condensation that is taking place, what will happen is the clouds will become very dense and they cannot hold the waters anymore. So what will happen? They will fall as precipitation. So they fall down in form of precipitation. Precipitation, when we talk about precipitation, we are talking about any forms of moisture that is falling from the cloud. It could be in form of rainfall. It could be in form of snow, or it could be in form of hail. So we are having the moisture falling from the atmosphere to the earth's surface. Once this water reaches the land, there are two things that are likely to happen to the water on the land. The water on this land, depending on the surface that it has fallen on, the water on the land might just run on the surface. The water that is running on the surface is known as the surface runoff. So we are having water running on the surface. It can run on the surface and flow back into the water bodies. It can flow back to the rivers, lakes, and eventually the water will reach the ocean, seas, and many other water bodies that we have. So once the water reaches the earth's surface, we are having surface runoff, or alternatively, it can fall on a surface that has cracks on it, or the rock material is permeable. A permeable rock material, we are simply referring to a material that can allow water to seep through it. So we are talking about permeable rocks, and you're simply talking about the permeable rocks are those rocks that can allow water to seep through it. So if the water falls on a permeable rock, then this water will infiltrate through, so that you are having the water seeping into the rock surface. If it seeps into the rock surface, the process is known as percolation. We can refer to it as percolation or the infiltration process. So water percolates into the rock surface. The water that has percolated into the rock surface has various purposes. We are having the plants on the earth's surface. So these plants will take up the water through their roots, so that this water will then go through the plant onto the barks, the leaves, and so on for various purposes in that plant. And finally, these plants, when heated with heat from the sun, will lose the water into the atmosphere. So plants also lose the water into the atmosphere through a process called transpiration. So we discover that the water that has been from the water bodies has undergone various processes. It has been recycled throughout to the extent that it comes back to the original process. So this process whereby the water is undergoing these various processes and at the end of it all, go back to the original process, and the process repeats itself. We say that the water has been recycled over and over again. So we end up saying that water has undergone a process that is called the water cycle. So we are having water moving from the water bodies through the process of evaporation. Cooling takes place. When saturation point is achieved, then condensation will take place, clouds will form, and further condensation leads to these clouds falling in form of precipitation. We are having precipitation can be in form of a liquid, which is rainfall. It could be as a solid, which is snow. Then we are having hail, and so on. Then this water, as it reaches the surface, may either run on the surface as surface runoff, or it may infiltrate into the rock surface so that percolation process or the infiltration process takes place. Plants now take in the water through their roots, and when the water reaches the leaves and barks and so on, it will lose the water through a process known as transpiration. So you discover that the water is again going back into the atmosphere. The whole of this process is what we are referring to as the water cycle. So that is how the water changes its states from one point of from one state into another state, from solid to liquid state. It is also important to note that animals will also lose water into the atmosphere. They will take the water out of the atmosphere as they drink, and also in one way or another they will lose the water into the atmosphere. In that, when the animals excrete, they will lose the water, they release back the water into the atmosphere. At the same time, we sweat at one point or another. So when you sweat, you also release the water back into the atmosphere. So we find that there is that continuous recycling that is taking place in the process of the uses of water on the Earth's surface. So that continuous recycling of water from one state to another is whatever we are referring to as the water cycle. So this is what we are referring to as water cycle. But through the process of the water cycle, we've discovered that the precipitation that falls on the Earth's surface has two processes that it undergoes. It either percolates into the rock, or it runs on the surface as surface runoff. So this brings us to another process that water is undergoing, and this is the groundwater. So groundwater, when you are dealing with groundwater, we are simply talking about the water that exists. Water that exists underground. So this water that exists underground is what is known as the groundwater. So this groundwater, it's simply obtained during the percolation process. So as water percolates into the ground, the water that percolates into the ground is trapped Water that is underground is simply trapped in tiny spaces between the pervious rocks. It is important to know that we've defined a pervious rock as that rocks that allow water So when you're having a rock that is allowing water to seep through them, then we are referring to that type of a rock as pervious rocks. So we are having water existing underground as being referred to as the groundwater. This groundwater is simply trapped in tiny spaces between the pervious rocks. So the water that is existing underground, it is trapped so that it is trapped between tiny spaces in the pervious rocks. And as it is trapped in these tiny spaces, what happens is that the rock is pervious. We've said that this rock is a pervious rock. Being a pervious rock means that it will allow water to seep through it. So since it allows water to seep through it, it will percolate. The water will percolate through the rock, and once it percolates through the rock, then it will move into the rock and moves to the lower layers of the rock. When water is moved into the lower layers of the rock, then the water that will be pumped out of. So we are having water on seeping through the pervious rock. Then as it seeps through the pervious rocks, it moves into the lower layers of the rock such that it is collected. And in the process, the water will be tapped onto the surface, maybe through wells. So we can dig a well, or we can dig a borehole, so that the water from the underground is now tapped onto the surface. So when this water is tapped to the surface, then we say whatever has been formed is an aquifer. So aquifer is simply the underground water that is being tapped onto the surface of onto the surface of the earth, maybe through the wells or through the boreholes. So that is what we need to know about the groundwater. But in the process of forming this groundwater, we have a very much important groundwater that we need to look at, and this groundwater that we require to look at is the Great Artesian Basin. So we are having the Great Artesian Basin. Great Artesian Basin is one of the largest This is one of the largest groundwater that is found in the world. So being one of the largest groundwater that is found in the world, we need to know, how did this Great Artesian Basin come into being, or how was it formed? So the Great Artesian Basin was formed many million years ago, and this is what happened, that there was water, that we have water from the rain that fall on the earth's surface, falling in seas and oceans, so that this water later on percolated. We are having some layers of we have layers of impervious and pervious rocks. So we are having a pervious rock, then we have below it a layer of impervious rock, and the alternating layers continue. So as we are having the alternating layers of impervious and pervious rocks horizontally placed, so this water percolates into the pervious rock. So we are talking about pervious rock. Pervious rock is the rock that will allow water to pass, to seep through it. Then impervious rock does not allow water to seep through it. So we are having impervious rock, and this one does not allow water. So pervious rock, it will allow water to seep through it, and impervious rock will not allow water to seep through it. So we are having alternating layers of pervious and impervious rocks. So water and moves from the land. So we are having a land movement of the land that was exposed, which then led to the exposure of the pervious rock. So this pervious rock allows the water to soak through it. So the water is moving through the pervious rock. But once it reaches the impervious rock, what happens is this impervious rock does not allow. So we are having water seeping through the pervious rock, but once it reaches the impervious rock, the rock does not allow the water to seep through it. So this water is then trapped in the impervious rock. So that water that is trapped in between the pervious and impervious rock is what is known as an artesian basin. So an artesian basin is formed when we are having water being trapped in between the pervious and impervious rock. So the water that was trapped there formed the Great Artesian Basin. So this is what we have. Whatever we are having at the base is the bedrock. We have the bedrock, then this bedrock, from the bedrock we have the impervious rock, then the next layer we have is a layer of the pervious rock on the surface. So we have a pervious rock, then we have an impervious rock. So we've already said that the pervious rock will allow water. So this is precipitation that is falling, maybe in form of rainfall. So as this rainfall falls on the surface of the earth, it meets the pervious rock, so it means the water will seep in. There are some cracks in the pervious rock, or the rock itself will allow water to seep in, and as this water seeps in, it will come to a point where it reaches the impervious rock. When the water reaches the impervious rock, this impervious rock does not allow further seepage of the water underground. So what happens is this water is then trapped. The water is then trapped in between the pervious rock and the impervious rock. So this water that is trapped in between the pervious rock and the impervious rock is what we are calling the artesian basin. So this artesian basin that has been formed underground, the water has to reach the surface of the earth. The water can either reach the surface of the earth through construction of wells and boreholes, or springs can cause this water to reach the surface of the earth, or alternatively, the windmill can be constructed. And when we are looking at the sources of energy, we talked about the windmill being one of the instruments that is used to pump water onto the surface of the earth in Australia, being the fact that it pumps water and supplies it to the largest part of the Australia. So we are having this water from the underground being pumped to the surface through the various processes, and then the water is used for the various activities on the earth's surface. So that is the underground water. And underground water, we are talking about the special part of the underground water, that is the artesian basin. So artesian basin provides us with the fresh waters that we use on the surface of the earth. So we are looking at the water cycle, and we've said that these waters undergoes various change of state, so that it moves from one state of matter unto the other. And in the process of water changing its state from one state to the other, there are various factors that will affect this water cycle. So we want to look at the factors that are affecting the water cycle. One of the factors that affects the process of water cycle is the state of water. Water can either be in solid state, water can either be in liquid state, and this water can either be in gaseous state. So we are talking about water in solid state. This could be snow, ice, and so on. Water in liquid state could be rainfall, all the waters in the water bodies, then waters in gaseous state, we are having the water vapor. So water, when it is in these various states, it can affect the water cycle in one way or another. When water is in solid state, that is water as ice or water as snow, this ice could be found either in the polar regions, that is the northern and the southern parts of the earth. We have these polar regions. It could be on peak of high mountains. and so on. So we are having ice that has accumulated either in polar regions or on peak of high mountains. This is still water that is supposed to undergo the water cycle, but it has accumulated on mountain tops and maybe the polar regions. Now that it is in this solid state, it cannot carry out much in the water cycle unless the ice melts into water. So unless the ice melts into water, so that as it has melted into water, it can then evaporate into the atmosphere, then the evaporation will now enable condensation and cooling to take place, then finally precipitation to fall down. But once it is still in the ice state, then it will not be much useful in the water cycle. So we find that the state of the water is going to affect the rate at which the water cycle is taking place. In that, if water is in solid state, that is in ice or snow, then it means that this water that is in ice condition will not be part of the water cycle unless it has melted into liquid. So it slows down the process of water cycle, since the ice has to go through the melting process first. So as it goes through the melting process first, it means that it has slowed down the process of water cycle. Then another thing is, these plants, we have plants that grow in regions that are experiencing very low temperatures, such that the area is covered, the land is covered by ice and snow. So what happens is, these plants are not taking in water. And since they are not taking in water, because the water is in ice state, so since they are not taking in water, it means the rate of transpiration is also slowed down. So if the transpiration rate has been slowed down, then it means the whole water cycle process is also interfered with. The next factor that affects, another factor that affects water cycle is air temperature. Air temperature, the air temperature can either be low or it can be high. So what does this mean? This air temperature will affect the rate of evaporation Air temperature will definitely affect the rate of evaporation and the rate of transpiration. For this water in the water bodies to evaporate into the atmosphere, then the temperatures have to be high. So if the temperature is high, the higher the temperature, high temperatures increases the rate of evaporation and transpiration. So when temperatures are high, then the rate at which the water will evaporate into the atmosphere from the water bodies will also increase. The rate at which these plants are going to lose the waters will also increase. So we are saying if temperatures are high, then evaporation rate and transpiration rate will also increase. But on the other hand, if temperature is low, so if temperature is low, then it means the rate of evaporation and the rate of transpiration will also reduce. Plants will not lose a lot of water into the atmosphere if temperatures are low, and at the same time, the water from the water bodies will not evaporate into the atmosphere if the temperatures are low. So we find that air temperature really affects the water cycle, in that if temperatures will be high, then the rate of evaporation is also going to be as fast as possible. But when temperatures reduces, because automatically there is a time in a day when temperatures will be high, and there will be a time in a day when temperatures will be low. So this will also affect, or it will also interfere with the processes of evaporation and transpiration. So air pressure really affects the water cycle. The next factor that affects water cycle So we are talking about humidity as another factor that affects the water cycle. Humidity is simply the amount of water vapor in the air. What is the amount of water vapor in the air? If the air has water vapor, excess water vapor, then we are saying that the air has reached a point where it cannot hold the water vapor anymore. What does this mean? It means that the air has reached the saturation point. So another factor affecting water cycle is humidity, and you're simply defining humidity as the amount of water vapor in the air. So we are talking about if this water vapor in the air has reached a point whereby the air cannot hold the water vapor anymore, then we say that the air has reached the saturation point. So at the point where the air has reached, if there is high humidity in the atmosphere, or if the humidity is high, what does it mean? That there is a lot of water vapor So if humidity is high, then there is a lot of water vapor in the atmosphere. And if the water vapor in the atmosphere has reached that we are having a lot of water vapor in the atmosphere, then it is going definitely to interfere with the rate of evaporation and transpiration. because if the air has reached saturation point, then it means the air cannot hold the water vapor anymore. So this means if the humidity is high, the rate of evaporation and transpiration will also slow down. In that, there is a lot of water vapor in the atmosphere, so it means evaporation and transpiration will slow down, so that there is no the water vapor that is available in the atmosphere should reduce fast for any additional water vapor to be added in that atmosphere. So high humidity lowers the rate of evaporation and transpiration, but when the humidity is low, then evaporation and transpiration rates will also be exaggerated, or they will be at a faster rate compared to when the humidity is high. Another factor affecting water cycle, we are having air movement. Movement of air, we are simply talking about the wind. Is the condition windy or is it calm? So we find that when it is windy, then evaporation and transpiration when there is a lot of movement of air in the atmosphere, then evaporation and transpiration is high. But when it is calm, the movement of air is very much minimum in the atmosphere. The rate of evaporation and transpiration so we are having a calm atmosphere, rate of evaporation and transpiration is slowed down. When there is a lot of movement of air in the atmosphere, evaporation and transpiration is high. So calm environment will slow down the rate of evaporation and transpiration, but a lot of movement of air in the atmosphere will make the rate of evaporation and transpiration to be high, which in turn will affect the water cycle as a process in general. The next factor that affects water cycle is the landscape. So when you're talking about the landscape, then we need to know what the word topography means. So we are having topography as the general appearance of the land. How does the land appear? The land could be hilly, or we could be having very steep slopes. There could be gentle slopes. This land could be covered with vegetation, or the land could be bare. At the same time, the soils on the land, we could be having soils that are permeable, or the soils that are having rocks that are permeable, and others could be impermeable. So we are having generally, how does this land appear? So the way the land appears will definitely affect the process of water cycle. For instance, if rainfall is falling on a steep sloped area, so what will happen is this water will not percolate into the ground, so it minimizes the percolation process but encourages surface runoff. So we are having steep slopes. We are saying on steep slopes, percolation is less, but surface runoff takes place. So we find that water that has fallen on a steep slope, then percolation process is going to be less, but the surface runoff is going to take place at a higher rate. Then we are talking about this water falling on a ground that is gentle and may be covered with vegetation. So we are having a gentle slopes. Then in addition to being gentle, it is covered with vegetation. So what happens to this type of a landscape? This type of a landscape, water falling on this type of a landscape will not undertake the surface runoff process, or the surface runoff is discouraged in this case. But what happens is we are having vegetations that will hold the water for a long time. Then we have a gentle slope. So these vegetation that are holding water for a long time on the ground, and the gentle slope encourages percolation process. So we find on a gentle ground that is covered with vegetation, then percolation is encouraged. At the same time, if the soils that are existing on that ground have some cleavages or cracks, then they will allow percolation process to take place. But if the soils that are available in that area are closely packed, then they will allow surface runoff to take place. So we find that the nature of the landscape will definitely affect the whole process of water cycle through the processes of percolation and surface runoff. The next factor that affects, another factor that affects water cycle is vegetation. Vegetation require water for various purposes. They require water, the roots take in water for growth purposes. We have vegetation require water for the process of making their own food and so on. So we find that these vegetation are having different adaptations depending with the area they are growing in. We have vegetation that grow in dry areas. So these vegetations that grow in dry areas, we find that the rate at which the roots take in water So the rate at which the roots of vegetations that are growing in dry areas will take in water is slower than the rate at which transpiration will take place. So since the rate at which the roots are taking in water is slower, then it means that these vegetations have to come up with a way in which they can survive so that they have enough water for their own use. So what will happen is you discover that most of these plants will have very narrow leaves, and these narrow leaves minimizes the rate of transpiration. So since the narrow leaves will minimize the rate of transpiration, it means the rate at which the water is being returned to the atmosphere is being reduced. So in the process, the water cycle is minimized. At the same time, we find that the leaves have spaces. These spaces are called the stomatas. So some of these plants will have to fold their leaves so that the stomatas are closed, and once the stomatas are closed, then in the process the rate of transpiration is also reduced, and in turn it affects in one way or another the process of water cycle. Then finally, the last factor that affects the rate of transpiration is the amount of sunshine. So when we were looking at the water cycle, we looked at the sun as the major source of heat on the Earth's surface. So being the major source of heat, then it means that the availability of this sunshine will definitely affect the rate of evaporation and the rate of transpiration on the Earth's surface. If the area experiences less sunshine, that is, maybe it is covered with clouds and so on, so it means that the sunshine is less experienced in that area, so it means that the rate of evaporation and transpiration will be lowered. But if the amount of sunshine is high, then the rate of transpiration and evaporation is also increased, which in turn definitely will affect the process of water cycle in general. So as we conclude on the water cycle, it is important to ask, is there any importance? Is there any need for this water to undergo all these processes? And we find that it is very much important for the water cycle process to take place. Why? Because due to the process of water cycle, it ensures that there is continuous supply of moisture in the atmosphere. So this continuous supply of moisture, we need the moisture in one way or another, the plants need the moisture in one way or another, and the animals in general also need this moisture in one way or another. So we find that it is very much important for the process of water cycle to take place so that there is continuous supply of moisture in the atmosphere. And as human beings who have brains, we can be in a position to make sure that we do not interfere with the water cycle. So let us take care of all the processes that are involved. Where we have control of it, can we take good care of the processes that are involved? Thank you. We come to the end of this topic.